Welcome back. If you're going to build, defend, or even just analyze any kind of digital system, you first have to understand your opponent. So today, we're deconstructing the adversary. We're going to dig into the foundational concepts of adversarial behavior, the who, the why, and the how, to really build a solid mental model of the threats we're all facing in cyberspace. Okay, so here's our game plan. We'll start with what's actually driving these attackers, their core motivations. Then we'll dissect their operational infrastructure, which is, you'll see, surprisingly sophisticated. From there, we'll look at how we as defenders can analyze their methods. And finally, we'll take a peek at the next frontier in this ongoing battle of wits. All right, first things first. To really get a handle on the threat, we need to get inside the mind of the adversary. It's not enough to just know what they do. We have to ask that more fundamental question. What's driving them? Why do they do it? So let's get a clear definition on the table. When we talk about adversarial behavior, we are not talking about accidents or, some user making a mistake. We are talking about a deliberate, conscious choice to break the rules of a system, not by accident, but with a specific malicious goal in mind. And this, right here, this is the key. While the tools of the trade are obviously highly technical, we're talking exploits, malware, botnets, the behavior itself is fundamentally human. It all comes back to a decision, a motivation. Understanding that human element is every bit as critical as understanding the code. The internet just offers some incredible advantages that really incentivize this kind of behavior. Now, of course, financial gain is the main engine here, but these other factors are just as big of a deal. Think about it. Reach and anonymity let attackers operate from anywhere on the globe. And crucially, this last one, compartmentalization, has professionalized the entire landscape. An attacker doesn't have to be a jack of all trades anymore. They can just specialize, creating what's essentially a supply chain for attacks. So let's see how this all builds from that motivation into a surprisingly organized, sophisticated operational structure. We're about to see that modern cybercrime looks a lot less like a lone hacker in a hoodie and a lot more like a well-run multinational business. Okay, this is a really important distinction to make. A cyber-enabled crime is basically an old crime with a new tool. Fraud has been around forever, right? But the internet gives fraudsters a global pool of potential victims. Cyber-dependent crime, on the other hand, well, it literally couldn't exist without the internet. Things like ransomware, they depend entirely on a complex digital web of malware, command and control servers, and cryptocurrency. This is a totally new class of crime, born directly from the technology itself. And because these cyber-dependent operations are so complex, we're really not talking about lone wolves anymore. What we're seeing is the rise of a specialized, service-based underground economy, where different criminal groups offer their unique skills as a paid service. This whole underground economy functions pretty much just like a legitimate tech industry. You don't need to write your own exploit. You can just rent an exploit kit that automatically does the dirty work. You don't need to build a massive botnet from scratch. You can just pay for access to an existing one. And these affiliate programs, like the ones used for ransomware, let criminals just focus on spreading the infection, taking a cut of the profits without ever touching the back-end infrastructure. It's a full-blown, modular, as-a-service model for crime. But with all this complex tech, we can never, ever forget the human element. This quote just nails the vulnerability that attackers exploit with social engineering. People either can't follow security rules because they're too confusing, or they won't because it's just inconvenient. And the adversary knows this. A good phishing email isn't targeting a software flaw, it's targeting this predictable gap in human behavior, turning people into an unwitting piece of the attack. So, now that we understand the why behind their motivation and the how of their operations, let's flip the script. How do we, as defenders, make sense of all this? How do we go from just reacting to incidents to actually systematically disrupting them? This is the million-dollar question for any security professional, right? An attack isn't just one single event. It's a sequence of actions. And if we can map out that sequence, we can find chances to intervene. The answer really lies in using structured models to deconstruct the adversary's playbook. One of the classic models for this is the cyber kill chain. Let's just look at a couple of key stages to get the idea. It starts with exploitation, which is that first moment the attacker's code runs on a target. That's followed by installation, where they plant something like a remote access Trojan, or RAT, to make sure they can get back in later. Now, while the kill chain is great for a high-level view, modern defense often uses more detailed frameworks, like MITRE ATT&CK, to map specific adversary techniques to each phase. And that is why these models are so powerful.
Each step in the attacker's process becomes a potential failure point that we can target. If we can knock out their command and control channel after the malware is installed, well, the initial exploit and the rat are suddenly useless. By understanding the whole sequence, we can get ahead of the adversary and break the chain.
All right, so where is all of this headed? The traditional fight has been on our networks and our computers, but the next frontier is already here, as attackers start to target the very logic we use to defend ourselves. This is a huge deal, and it's one of the most important emerging trends in adversarial behavior. As we start to lean more and more on machine learning and AI for defense, it's only natural that attackers are now turning their attention to attacking the models themselves. And this has kicked off an entirely new field, adversarial machine learning. We're not talking about finding a simple bug in a firewall's code anymore. We're talking about crafting input that is specifically designed to fool an intelligent system into making the wrong call, to see malware as safe, or to ignore a major network intrusion. It's about turning our own automated defenses against us. The threat here kind of comes in two flavors. On one hand, you have evasion attacks, where an attacker just slightly changes their malware so it can slip past a trained model. But the second type, data poisoning, well, that is way more insidious. This is where an attacker actually injects malicious data into the training set itself, corrupting the model from day one so it never even learns to spot threats correctly. You can see how this just completely changes the game, right? It's no longer just humans attacking systems that are defended by automated rules. It is becoming a battle of algorithms, an arms race between automated intelligent attacks and automated intelligent defenses. And that's the question I really want to leave you with. As this cat and mouse game gets faster and more automated, what does it mean to be a defender? When adversaries can poison our data and evade our algorithms, the role of the human has to evolve, from just operating the tools to designing more robust systems, to understanding the limits of our models, and hunting for the threats that even our smartest machines will definitely miss. That's the real challenge for the next generation of security pros.